Hello students, in this video we're going to do a quick revision. There are two parts to this video. The first part we'll talk about primes, factors and multiples. The second part we'll talk about real numbers. Let's look at what we're going to learn in the first part of the video. We'll be learning the difference between a prime number and a composite number, learning how to find a prime factorization using the factor tree or the repeated division, finding HCF and LCM using prime factorization, finding square roots and cube roots using prime factors, and of course, solving some real-world everyday problems using HCF and LCM. Let's look at what is a prime and what is a composite. I have some numbers on the screen and I'm going to classify them under prime or under the composite. So let's start off by having the number 8, 6, 9, 100, 4, and 21. And then under primes, we will have 2, 3, 5, 7, and 11. All right. So the number 8, we can write it as 1 times 8. 1 times 8 gives you 8. Or 2 times 4 gives you 8. So therefore, the factors of 8 are 1, 2, 4, 8. So for 6, it's 1 times 6 or 2 times 3. So factors are 1, 2, 3, 6. All right, we're not going to do the rest. So let's look at the number 2. 2 basically is just 1 times 2. So the factors are 1 and 2. And then 3 also is just 1 times 3. So factors are 1 and 3. Right. So therefore, we can see that a prime number has only 2 unit. Unit meaning different. Has only 2 unit factors, 1 and itself. So to be a prime number, you can only have 2 unit factors, 1 and itself. 1 and yourself. That means if you're number 3, then the factors are only 1 and 3. If you are 11, the factors are only 1 and 11. However, a composite number is such that it has more than 2 factors. So a composite number has more than 2 factors. Right. So the next question is, how about the number 1? Let's look at the number 1. The number 1, it's equals to 1 times 1. So to be a prime, the definition is such that it must have 2 unit factors, 1 and itself. 2 unit means 2 different. So 1 has only 1 factor. That is 1. And it's also itself. So therefore, the smallest prime number is 2. 1 is neither a prime nor a composite. Next up, let's look at how we can do prime factorization. Supposing we are asked to express 616 as a product of its prime factors and also to express it as index notation. How do we go about doing it? The two ways of breaking 616 as a product of its prime factors, we can do it using the factor tree. Right? You start off by dividing 616 with the prime number 2, and you have 308. And 308 is divisible by 2 and 154. And so 154, you can actually continue to divide it by the number 2 and 77, so on and so forth, until finally all the numbers that you have are all prime numbers. So that is factor 3. Another way of doing it is using the repeated division. And we will arrive at the same results. That is 2 times 2 times 2 times 7 times 11. Okay, so all these are prime factors. So this is what it means by expressing 616 as a product of its prime factors. So what is index notation? You see that 2 times 2 times 2, 2 times 2 times 2, we can stack it up to get 2 to the power of 3. So if you write 2 times 2 times 2 as 2 to the power of 3, then this format 2 to the power of 3 is called the index notation. Right, so the number 3 here, it's your index, and 2 is your base. All right. Right, one very useful applications of prime factorization of a number is to use it to find HCF and LCM. Supposing I'm asked to find the HCF and LCM of these two numbers, 60 and 75, using prime factorization, how do I go about doing it? Yes, first of all, we will have to use either the factor tree or the repeated division to break 60 as a product of its prime factors, and also the number 75 as a product of its prime factors. And the next thing is that we're going to write it as index notation. So 2 times 2 times 3 times 5 can be written as 2 squared times 3 times 5 for the number 60. For the number 75, it's 3 times 5 squared. So we have to arrange it properly. The number with the same base, this is base 5. You put it in the same column. This one is base 3, same column. If you look at 75, it's just 3 times 5 squared. So it does not have a base 2. So what do? You just replace it with the number 1. Let's look at the next step. So to find the HCF, we actually compare the two numbers and we pick up the smallest one. So between 2 squared and 1, we take 1. Between 3 and 3, of course, you have to take 3. Between 5 and 5 squared, you take 5. So the HCF will be 1 times 3 times 5 gives you 15. So for LCM, it's the other way around. We pick the bigger number of the two numbers. So between 2 squared and 1, we pick 2 squared. 3 and 3, we have to take 3, no choice. Between 5 and 5 squared, we take 5 squared. So 2 squared times 3 times 5 squared will give you 300. So this is how we can find HCM and LCM using prime factorization. Prime factorization is also very useful finding square root and cube root of a number without using the calculator. Supposing we're asked to find the square root of 676. How can we go about doing it? Yes, let's use repeated division to break 676 into the product of its prime factors, where we get 2 squared times 13 squared. Right, so square root of 2 squared times 13 squared it's equals to 2 times 13. One way to look at it is just to take the index 2 to divide by 2. So basically finding square root means there's a little number 2 outside the radical symbol. This is called the radical symbol. Usually we don't put the 2 there, right? So times 13 2 over 2. So you end up getting 2 times 13, that gives you 26. Another way of looking at it is we need to have two groups of similar term. So we can group them as 2 times 13, one group, and then another group is 2 times 13. So I have two groups of similar terms. To find the square root, I just take out one of them, which is 2 times 13. And that gives you 26. Right, so how do we find the cube root of 729 without using a calculator? Yes, first of all, we will have to use the repeated division to break 729 into product of its prime factors. And what does cube root means? It means that we have to classify whatever we have into three groups, and these three groups must have similar terms. So you see that we can classify it into 3 times 3, one groups, another 3 times 3 is the second group, and then 3 times 3 the third one. So there are three groups, each of them they have the similar terms 3 times 3. So the cube root of it will just be 3 times 3, and that gives you 9. Another way is to use the index notation, write it as 3 to the power of 6, and you just take 6 divided by 3, the index 6 divided by 3 to get 3 to the power of 2, and 3 to the power of 2 is 3 times 3, that get you also end up getting the same answer. Let's look at how we can use the concept of prime factorization to solve some problem. Supposing we're given a number m such that 36 times m is a perfect cube, we are asked to find the smallest possible integer value of m. So how do we go about doing it? What is an integer? An integer basically is just a whole number. So we can have positive or negative integer, and including 0. 0 is an integer, but it's neither positive nor negative. First of all, we have to use the repeated division to write 36 as a product of its prime factors. And yes, perfect cube means we need to have three groups of similar terms. So 36 is equals 36 times m can be written as 2 times 2 times 3, 2 times 2 times 3 times 3 times m. And as the products, we need to have three groups of similar terms. So therefore, we will need to have 2 times 3, one group, another second group, and the third one. Okay, we're going to distribute what we have. So we have 2 that goes into your first group, 3 goes into your first group, the second 2 go into the second group, the last 3 go into, right? So what do you think your m is? Yes, the m will have to be 2 times 3. Let's look at the next questions. We have Ahmad, Brian, and Clara, and they go to a cafe for dinner on regular intervals of 6 days, 8 days, and 15 days, respectively. If all of them go to the cafe on the 1st January 2019, what is the next date that they will go together? They will go again. So we have to consider if we need to find the HCF or the LCM. So which concepts do we use? Yes, we will have to use we will have to find the HCF of 6, 8, and 15. because the next date will happen many days later. So that it's finding the number will get bigger and bigger than 6, 8, 15. Hence, we're actually finding the multiple of these 3 days. So first step is to use repeated division to write 6, 8, 15 as a product of its prime factors in index notation. And so therefore, the lowest common multiple of these 3 numbers are 2 cubed times 3 times 5, and that it's 120 days. So they meet on the 1st January. So in January, we have 31 days. February, we have 28 days. 2019 is not a leap year, so there are 28 days. March is 31 days. April, 30 days. If you add up all the number of days, that is 122. So therefore, the next time they meet will be on 1st May 2019. Let's look at the next question. We have the total sales of a particular model of calculator on 3 days, $180, $414, and $306 respectively. Part A, we are asked to find the greatest possible price of the calculator. Part B, hence find the total number of calculators sold on the 3 days. So in this questions, what do you think? Do we find the HCF or the LCM? Yes, greatest possible price. If you see the word greatest, it refers to finding the highest common factor. So we use repeated division to write 180, 414, and 306 as a product of its prime factors in index notation. And from there, we have 2 times 3 squared times 1 times 1 times 1, that gives you 18. So therefore, the greatest possible price of the calculator is 18. That's for part A. And for part B, how do we find the total number of calculators? Yes, we take the total sales, that's 180 divided by 18, plus 414 divided by 18, plus 306 divided by 18. Or you can simply add up all these total sales for the 3 days and divide by 18. You will still get the same answer, and that is 50 calculators. For part 2 of this video, we'll learn to identify rational, irrational, and real numbers, and performing all 4 math operations on real numbers. Let's start off by representing all these different types of numbers on the number line. Let's start off by recurring, terminating, negative 2.50, 1.25, or the number 4, they are terminating numbers. Rational numbers basically are just fractions. Irrational numbers are numbers such as negative pi, square root 2, or the symbol e. And what are real numbers? Real numbers are any numbers that you can find on the number line. Right. So recurring numbers are numbers such as 2/3. If you were to use a calculator, you will have 0.66666. So you see this number 6 recurs. So this 2/3 is called a recurring number, and sometimes you can write it as you will have a little dot on top of the number 6 because the 6 is the one that repeats. That's called recurring, or sometimes it's called repeating decimal. Negative 4/3, it's also a recurring decimal because it's negative 1.33333, so on and so forth. Right, so terminating numbers are numbers such that the number doesn't continue. For example, like negative 2.5, you see it stops at 5. Or the number 4, it just stopped there. Terminating means you stop there. You don't have so many decimal like 2/3, 0.66666 keep recurring. Or for example, like okay, if you were to use a calculator to work out square root 2, you'll see it's 1.4 something. It just keep repeating. So that it's a non-terminating, or it's also irrational number. Okay, so likewise also pi is 3.142, so on and so forth. Many decimal numbers behind, so that's called irrational. Basically, you cannot write irrational number as a fraction. So rational numbers is, you can write it as a fraction, like 2/3 is a rational number, or even a 4 is a rational because you can write it as 4/1. So any numbers that you can find on the number line are considered real numbers. Right, in the next questions, we're going to represent the numbers listed on the given number line. We're going to put the numbers correctly on the number line. So on the number line, we'll have a divider that is 0. On the right hand side of your divider, 0, that will be 1, 2, 3, 4, 5. On the left will be -1, -2. All right, so where do you think 4.5 lies? Yes, 4.5 is between 4 and 5, so we put a little dot here, put the arrow, and then put the number on top of the arrow. So that's my 4.5. -3/4 is -0.75. -0.75 will be in between 0 and -1, so that will be here. And then square root 4 is square root 4, it's square root 2 times 2, and that gives you 2. So 2, the number 2 is here. Put the arrow and put square root 4. All right, so -1/3, we have learned just now, -1/3 is a recurring decimal. Okay, so it's between 0 and -1. So should be somewhere here. That's -1/3. All right, so that's how we represent the number listed on the number line. The second last slide, we're going to evaluate each of the following without using a calculator. Let's look at the first question. Right, so we have a -16 times -3. So negative multiplied with a negative, that will give you a positive number. So that will give us positive 16 times 3, that is 48. So usually positive 48, we will write it as 48. We don't have to write the positive in front. Okay, so these two are done, and then we have to work out the times first. So the negative is there, so we continue writing the negative, and then we bracket it to find the answer for -8 times 5. So negative with a positive 5 means positive 5. So negative times positive will gives you a negative. So that gives us -40. 8 times 5, it's 40. And negative times negative give us a positive. So that will be 48 plus 40. So you would have 98 as the answer. Okay, let's look at the next one. All right, so we will leave 2/3 alone first, and we have to work out the ones in the bracket. So we're going to find the lowest common multiple for 4 and 8. And that is 8. So that will give us 2 minus 1, 1/8. All right, and then next step is I need to work out the one in the bracket again. That is 1/8 times another 1/8. So that will give us, multiply these two together. Wait, hang on. We have to work this out first. So that will give us 1/64. And 2 times 1 gives you 2. 2 times 32 gives you 64. So 1/3 times 32, that will be 32 times 3, 96. Okay, so this is how we do it. Let's look at the last one. Okay, we're going to leave -2.5 untouched first. We're going to work out this. So to work out that, I need to work out -1/2 with -1/2, another -1/2, because it's to the power of 3. minus 1/4. Okay. We'll work out the one in the bracket first. So negative times negative will be positive. With another negative, there will be negative 1/8. So you need to have patience when you do this. You just basically have to work things out one at a time. So we need to solve this by finding, you need the lowest common multiple of 4 and 8, that is 8. So that is negative 1 minus, this is times 2 minus 2. So that gives us a negative 1 minus 2 will be negative 3/8. Alright, so I will need to multiply these two together. However, I would have to change this to a mixed number. And that is negative 3 times 2, 6 plus 2, 8/3. Alright, I have to work this out first. So basically that gives us 1. Negative 3/8 times negative 8/3 will be 1. So that's negative 2/3 minus 1. And that gives us negative 3 and 1/3. Alright. Right, the last slide of the video is for those who are interested to know how to convert recurring decimal to a fraction. Supposing we have a recurring decimal 0.11111111, how are we going to convert that to a fraction? So we're going to let x equals to 0.111111. We're going to multiply it with 10. So x times 10 will give us 10x. Just like, for example, you can let x to be 1 apple. 1 apple equals to 0.1111. So times x means 10 apple, and 0.111 times 10 will give you 1.11111. So the next step is I'm going to take 10x to minus 10 apple minus 1 apple. That gives you 9 apple. So that gives you 9x. And if you take 1.111111 minus away 0.1111, basically you end up getting 1.0000, which is 1. So 9 apple equals to 1. So 1 apple is just 1/9. So if you use your calculator and take 1 divided by 9, you will get 0.11111. Okay. So for let's look at the next one. Supposing I have this recurring decimal 0.23232323. Right. So I can't multiply by 10 anymore. I have to multiply by 100 because the purpose is to get rid of all this decimal number. And you can only do it if you multiply by 100 because 0.232323 times 100 give you 23.2323. And if you use your calculator or don't need calculator, if you take 23.2323 minus away 0.2323, you end up just getting 23.0000, which is approximately to 23. So you will have 100 minus x gives you 99x. So 99x equals to 23. Therefore, x is 23 over 99. What happens if you have 0.169169? Then you will have to multiply it with 1000. Okay. So the pattern is such that if you have the number to one decimal place, you multiply by 10. If you have a number that is not one decimal place, sorry. If the number just repeat itself like 0.111, it just multiply by 10. If it's the number 0.2323, or you multiply by 100, 0.169169 multiply by 1000. So if it's 0.1234, 1234, 1234, then you will just have to multiply it with 1, 2, 3, 4 zeros, okay, to find your 10,000x. And that's all for this video.